Hello, I'm your host, Grayson Brulte. Welcome to another episode of SAE Tomorrow Today, a show about emerging technology and trends in mobility with leaders and innovators to make it all happen. On today's episode, we're absolutely honored to be joined by Vlad Voronensky, co-founder and CEO, Helm AI. On today's episode, Vlad and I discussed Helm's approach to developing a hardware-agnostic approach to self-driving. We hope you enjoy this episode. Vlad, welcome to the podcast.
Thanks for having me.
It's great to have you here. AI is changing the world, and for us and what we're interested in, it's changing the way we drive. It's becoming autonomous. How is Helm approaching autonomy?
So we're primarily focusing on the software aspect of autonomous driving, and that we're building full stack AI software for OEMs to use for their high-end ADAS at volume production deployments. The end goal for us is full autonomy L4, but we believe the best way to get there is to actually start with assisted driving systems, hence why we pursue the software licensing business model with OEMs. And technologically, what we're providing is essentially a scalable approach to developing AI software for autonomy that really unifies L2 plus all the way through L4. And in order to do that, we leverage large-scale unsupervised learning and a brand of it that we call deep teaching, which we've been developing internally since 2016. We started with the perception stack, which is critical as a starting point. But these days, we're building a lot of new capabilities for the full stack, including intent prediction, path planning, and also generative simulation.
Licensing model is the hottest thing going now. I was talking to a company that I thought was going under, and they explained to me, no, we're pivoting to a licensing model. Oh, this is interesting. It seems that that's the hottest thing going now. When did you embrace the licensing model? Was it on day one you saw something in the market that where we are today, or is this a recent pivot into licensing?
Yeah, so our business model was forged a long time ago, I think as far back as 2017. It really just took some thinking through what it would take to deploy a scalable L4 system. I pretty quickly realized that you have to start with assisted driving. So we've been working with OEMs since the very early days. So it's not a pivot for us. It's actually been our primary direction.
It's smart. Was your deep teaching approach, was that always embedded from day one as well?
Yeah. So, I would say that, in the very beginning, we kind of asked ourselves the question, right, in 2016, what would it take to actually win in this space long term? What would be our core advantage, right? And at that time, pretty much all the AI approaches were supervised, and that was clearly not going to scale. And we knew that we'd have to develop eventually unsupervised learning. So we figured we'd kind of lean into our strengths and really go into that direction. So that was probably one of the first things we decided to do, even before the business model was fully defined.
How do you see unsupervised learning evolving? Obviously, we have the latest versions of FSD. We have Wave. It seems that it's starting to become a trend now, which eventually will become a snowball effect, and you're a part of that.
Yeah, I think unsupervised learning, certainly coming into its own, so to say, and the same kind of success that we've seen with large language models, where you're predicting the next word in a sentence. I think we're already seeing analogous developments that are going to be a huge accelerant for the autonomous driving space. Essentially, if you take sensor data, video data, any kind of temporal data, predicting what happens next is critical for self-driving, and it actually encompasses things like intent prediction, path planning when properly formulated, and has bears a lot of similarity to, again, predicting the next word in a sentence. So, I think that self-driving will have its own kind of like ChatGPT moment soon enough.
It's coming. On the lines of the ChatGPT moment, what is unsupervised learning? Is it scale? Is it the ability to master corner cases, edge cases? What does it truly unlock, in your opinion?
Yeah, so very importantly, it allows you to train on a very large amount of data. And the thing that you need as well is you need to have a learning objective that is sufficiently informative, right? There's a lot of ways to formulate unsupervised learning. So yeah, from on a deep teaching side, we kind of leaned into our expertise in mathematical modeling and techniques from applied mathematics that made unsupervised learning much more efficient. But yeah, generally by allowing you to train on a lot of data, provided that you have this sufficiently informative learning objective, you just get to absorb a lot of information that would be way too cumbersome to model, right? So if we take a video sequence from driving and we learn from that to predict what happens next, you'll end up learning a lot of kind of human-like driving behaviors that would be pretty much impossible for a human to handcraft. And yeah, essentially you want to train models that are already aware of a lot of things so that when something crops up, there's always going to be surprises, but you don't want to have to go and retrain your model every time there's a surprise. You want the model to already be aware of a lot of things. And, in terms of reducing the burden on corner cases, with sufficiently advanced foundation models, you can basically reduce corner case resolution to prompt engineering, right? And especially in the cases where the data is very rare, that's going to be your only option anyway.
There was an individual, he wrote a fascinating book last year. His name is Jim Simmons. Jim Simmons was a World War II code breaker, became famous, and I went to Stony Brook in Long Island, ended up becoming the founder of Renaissance Capital and invented algorithmic trading on large data models, and did really well for himself because he was able to find anomalies in the data sets. It seems that that's what you're doing through your deep teaching. You're finding those anomalies and fixing them. In his case, he profited handsomely on them. And in your case, you're going to make the car drive better. So it's a little bit of an interesting comparison there. Obviously, Mr. Sim was able to get all the market data there. How is Helm gathering your data models? Do you have vehicles on the road today that are gathering that data to train, or how are you gathering that data?
So firstly, it's funny you bring up Jim Simons. I used to be an applied mathematician, and when I was at MIT, ran into him there a few times. And actually, I would say that he was actually kind of an example for me in some sense, because it was an example of a mathematician going into industry and being enormously successful. And, in the early days of Helm and still now, our hiring strategy is actually similar to more of like a, quant shop where we hire a lot of people with strong quantitative backgrounds. But regarding our data collection strategy, we leverage kind of publicly available data. There's quite a lot of it out there. So the early foundation models that we trained in 2017 just leveraged basically internet data like dash cam footage. And, we also have our own fleet collecting data. Our fleet is pretty small, so it's not really a large scale data collection effort, but we also work with OEMs, right? And OEMs, as you go to production, there's a scale up in how much data collection happens. And in the course of those partnerships, right, we of course get data from OEMs to fine tune the models. So it's basically a three-pronged approach: publicly available data, our own fleet data, and kind of very scalable fleet data from the OEM partners.
How much of that data is actually usable for your models? Are you throwing out a large chunk of it, or is there a majority of it helpful for your models?
Yeah, with any data set that's kind of collected in in a natural setting, there's going to be some repetition, or not like literal repetition of data, but kind of a lot of correlation between different data points. So you don't necessarily care about each data point as much, but there's techniques to handle that. So that's not necessarily an issue. And again, this is where kind of the generative simulation stuff comes in, right? So any data set you observe out there in the wild is going to have some distribution that is likely not perfectly adapted to building an AI model. It's just, again, the things that happen very infrequently just will contribute very little to your learning. But yeah, that's where we can leverage generative simulation to essentially create highly realistic synthetic labeled data sets that can focus on any given kind of corner of that data set.
Is your Gen 1 sim product your competitive advantage?
It's one of them. I would say that there's kind of a number of advantages. So, there's business model advantages and technology advantages. I mean, from business model side, again, we've been focused on this approach for many years. We've built strong relationships with OEMs. We're on our way to production, and so that I think, building relationships with OEMs is not a quick process. So I think that gives us an advantage for sure, because I think the entire industry was very focused on L4 as the only path in autonomous driving for a number of years. Technologically, I think our advantages come from kind of combination of skill sets in applied mathematics and deep learning, the innovation and deep teaching. Yeah, so we've already trained a whole slew of foundation models for perception. We've been doing that for years, and that's what allowed us to develop our perception stack and really bring that to a high level of maturity, such that it's something that can actually go into production. And for the more recent developments, right, like GenSim, and there will actually be a number of other. I mean, we already made other announcements about foundation models for intent prediction and path planning, and there will be many more actually in the coming months. But essentially, what we're building is a unified approach for developing L2 through L4. So that means that for any given ODD, any given production requirement, we want to have a process. Once you specify what you want, we want to have the same development process to build the optimal AI stack for that production requirement. And I think that unified approach is ultimately our competitive advantage. And it's one of those things that, yeah, there's been quite a lot of innovation to get to that point, right? If you asked me 2 years ago, what would that look like? I didn't have a clear answer. Now we have a pretty clear answer for what that is.
I've been having conversations with a lot of large institutional investors lately, and we keep talking about the developments of FSD and Wave, and the conclusion that we've been coming to is that you have to have a light stack in terms of cost efficiency, where the Waymo stack is going to be very expensive to scale. And we've been debating, does Waymo have to do a Waymo light stack that can go into lower forms of automation? How light is the Helm, what you're developing stack? Because if you need to say, okay, you have to put, so let's just use a publicly available number, $225,000 of sensors on a vehicle for it to work. It's not very scalable. You talk to OEMs, every penny counts when you're talking to an OEM. How light is the Helm stack?
Yeah, so this is actually an important part of our approach, is that we're essentially hardware agnostic, right? So we focus on the software. We have a development process that, for any given hardware, for any given compute stack and sensor stack, we can basically build the optimal AI. And so what that allows us to do is work with OEMs on any given production program, right? So in terms of how light the stack is, it's not just a decision Helm makes, right? It's a decision that OEM makes, and we can make the decision together, right? But essentially, we have processes for, kind of squeezing as much as possible from a given hardware configuration. But the point is that it's, OEMs will choose to differentiate their ADAS system, based on how they want to sell cars, who their target audience is, right? For any given ODD, there's kind of a law of nature for how much compute you might need, right? Or what kind of sensors you might need. And then there's like the optimal AI software that you can possibly put on there. So that's the part that we do, but we do it agnostically to, we don't necessarily come in with a hard requirement on the hardware. So there's a whole spectrum of production programs that we're able to work with. And also, as to your point regarding kind of the variance across these stacks, I think it's interesting because there's approaches to L2 that don't scale to L4, and there's approaches to L4 that don't scale down to L2, right? Like for L2, if you're doing something very cumbersome and very bottlenecked and supervised learning, it's not going to scale to L4. If your approach to L4 requires HD maps and like super precise localization with a LiDAR, teleoperation, infrastructure assumptions, it's just not going to scale down to L2 necessarily. So this is where I think kind of that unified approach becomes very important. And, leveraging the kind of large volume deployments in L2 plus as a way to, essentially a shared validation framework toward L4, I think becomes very important.
There's adaptability in your model. Well, there's adaptability. I'm curious, to run some of the algorithms in the driving takes a lot of compute, a lot of power in vehicles. Does that play a role when you're OEMs? Because what you describe is that I would say a relationship with an OEM is a relationship. You're not saying, okay, here it is, bolted on, figure it out. You're clearly stating that you work with your OEM partners. What role does power and compute play into that?
Yeah, I mean, so firstly, yes, it's true that our business model involves a lot of adaptability, and I think that is a key advantage, right? We're a software only provider by design, and we're able to work with any of the leading chip platforms. As far as compute power, yeah, I mean that's a hugely important variable for any given production requirement. I think that it's kind of a combination of factors that go into it, right? There's kind of what is available on the market, right, for a certain price in a given year, right? There's kind of strategic decisions that an OEM makes about where they want to go on the compute side, both in terms of the vendor and how much compute they want to put on the cars. I mean, the trend you see with Tesla is that they're aggressive in putting a lot more compute on the car, and then kind of leveling up the software, right? And that's where you get interesting outcomes like Tesla FSD. In the earlier days, like several years ago, I would say that there was still like a lot of friction in going from like lower compute to higher compute. But I mean, since then, there's been a lot of adaptation in the industry, and OEMs understand that software is going to be the key differentiator. You just have to put more compute on the cars. You have to go with a centralized computing platform. So, yeah, I mean, I think a lot of those questions, those early questions have been resolved, and now it's less about I think for most OEMs, maybe it's like less about a question of strategically wrapping their head around it, more just like, okay, well, yeah, like how much exactly do we target? But the centralized computing architecture is kind of becoming more standard.
It's becoming standard, and certain OEMs are doing it right from a software perspective, and some are doing it poorly. And I believe that you alluded to this, but the consumer's going to opt for the best software, I think, at the end of the day, especially as we go into higher forms of automation. They're going to infotainment. They're going to want software that just works at the end of the day. They're not going to want clunkiness. Your approach is, I'm thinking and looking at the market, seems I'll use a little bit like Mobileye. How would the Helm approach differentiate from the Mobileye approach?
Yeah, so they're actually quite different. I would say that Mobileye is a hardware software bundle and kind of more of a black box system. And where that comes from is that really their business model was formulated in the very early days of really, it wasn't autonomous driving, it was like safety features basically 20 years ago. So things like that alert you when your car is veering out of a lane or something like that, or about to hit a vehicle. So there you're talking about something like off the shelf. It's like an off the shelf component that an OEM might buy to satisfy safety requirements, right? Of course, you can also use those features to develop certain levels of autonomy like L2 and above. But once you go with the hardware software bundle approach, it's a very particular business model, right? And certainly you cannot be hardware agnostic in that context, right? Because that's going to be half your business is the hardware. And there's also, because of this kind of off-the-shelf aspect, there's not going to be much variance on the features. It's kind of like everybody gets the same features. And, if you're an automaker looking into the future and you ask yourself, okay, well, in some number of years, again, it's already happening. Software is the key differentiator. If the thing that I'm buying is the same thing that any other OEM can buy, how is that helping me, right? At most, I'm going to get a baseline. And if I can't even develop on top of that baseline easily, how am I supposed to innovate on top of this, right? So again, whereas with Helm, it's kind of much more aligned with the asymptotic game theory of the automaker and that, we provide software that can work with any hardware platform and is easily adaptable. So it's really kind of checking off some very important boxes for the strategy of our customers, right? So yeah, I would say that from a business model and product perspective, like they're quite different.
Options. I would describe it as options. You're giving your partners and customers, the OEMs, options to choose. You're not locking them in to a bundle. And that makes a big difference, especially from a cost-conscious perspective, but just from a technology innovation perspective, as we all seen what happens with the price of LiDAR. It started appearing and straight down. And then there's the debate, do you even need LiDAR? Can you do it with camera? Are you going to need radar? Are you going to need 4D radar? I like the approach where you're not locking your customers into a certain set of requirements. You're giving them the adaptability that they need to succeed as a business and that their customers want as well. So let's call Acme OEM, for example. You have a contract with Acme OEM, and let's say we have let's say a sub $35,000, sub $40,000 vehicle. Hey Vlad, we really love to put an L2 adaptive braking system on here for lane follow perhaps. And then we have a higher end vehicle, say it's north of 80,000. We like to put an L3, a high L2 system, an L3 system. Is that how adaptable your technology can be depending on the needs and the wants of your customer, the OEMs?
Yeah, absolutely. So, I mean, we've gotten, requests for quote for production programs that vary all the way from kind of safety feature type, L1, all the way through like L4. So, and we're able to work in any of those contexts. I would say that the sweet spot is kind of high-end ADAS, because L1 is a more kind of saturated market. But yeah, we certainly work along that entire spectrum.
From a development standpoint, from the Helm side, are you developing two separate stacks? On one side of the house, you have your L2 plus team, and on the other side of the house, you have your L4 team? Or is this one piece of software that your team is developing together?
Yeah, so it's a good question. So we really don't have a distinction between the two, in a sense that, I mean, the way to think about it, right, is for either an L2 or an L4 production requirement, they can be very different requirements. L4 it's going to have a much higher level of safety required, right? That implies there's going to be a lot more compute on that vehicle, right? And maybe a different sensor stack. But ultimately, what we have on the back end are basically, these foundation models, these huge neural networks that are not meant for running on the car. They're too big for that, right? But they're big enough to be able to support any of the production requirements, right? So they really enable a development process that flows down to either that smaller, lighter weight stack for L2 or the heavier compute stack for L4. But yeah, I mean, that's the thing is like it's, and again, this has only become possible in the last few years, being able to do this in a unified way and having confidence that it really will scale. But yeah, there's really not a distinction, and that's very important for our development process.
Are you seeing any demand from your customers for an L3 solution, or do you think the market just becomes an L2 plus and an L4 and L3 kind of fades away?
Yeah, that's a good question. Yeah, I mean, there's certainly demand across the entire spectrum, including L3. But yeah, I do think that L2 plus is kind of the more successful category right now. And essentially what it comes down to, right, is that for L3, you basically say something like, okay, well, it's autonomous, and we give you some period of time where we give you a longer period of time where we hand it off to you, right? The issue with that, of course, right, is that there can be scenarios that would imply L4 capability in order to actually make that possible, right? So a lot of L3 systems have this kind of restriction where it's something like, okay, we have to stay in our lane, and basically we're basically it's L3, but like the ODDs, we can't change lanes. Well, not changing lanes is also can be unsafe in some situations, right? So it's clearly suboptimal. And if there's like there's a speed requirement, like, oh, it can only go up to like 30 miles an hour. It's essentially a traffic jam assist or something like this, right? And also the volumes tend to be small, as a means of, I think as a means of limiting liability. So yeah, I think that L2 plus will be quite successful, and I think there will certainly be an increase in ODD for L3 as well, especially probably in low speed scenarios. I could definitely see even in complex urban environments, but at slow speeds, I think increasing the ODD for L3 makes sense without making the full jump to L4. But I think for higher speeds, and there's a certain segment of the ODD space where going into that segment with L3 implies you're going to L4. And I think it's a non-trivial part of that space.
The ODD is going to have to expand for the customer. The value proposition is going to have to be there. To spend $10,000 to be able to only go on a certain stretch of highway, consumers aren't buying it. We have data to back it up. There's reports, this is California DMV data. Mercedes-Benz only sold one Drive Pilot-enabled vehicle in California so far. One. It's not exactly flying out the door, and we have data. Look at how many Tesla FSD subscriptions they sold. It's a lot more than one. It's in the thousands. But you make an interesting point where if you're in San Francisco or you're in Los Angeles and you're in bumper-to-bumper traffic going down a certain city, or in LA going down Sunset, okay, that works great. It could take you an hour to go from Beverly Hills to Brentwood, and it's 3 miles, but it's just bumper-to-bumper traffic. That makes a lot of sense, and there's a lot of value there. I still question the market for the L3 product, though. Overall, when these products rolled out, either an L2 plus, an L3 system, an L4 system, will we continue to see the trend of starting in the higher end vehicles first and then working their way down to the lower cost vehicles? Or does that change when the BYDs enter the market? We had news today out of the Financial Times. BYD has now entered Europe. And I believe, in my opinion, it's only a matter of time till they enter the U.S. market. Does that shift the cost curve when that happens, or do we always stay at that upper end of the market to start?
Yeah, I mean, I think that in many cases, starting at the higher end is natural, right? For the automakers, it makes it easier to put more compute on those cars, and consumers that buy the high end vehicles will have an easier time absorbing the cost of an ADAS stack. I think that there can be a quick progression from high end to medium end to low end for a given OEM if the first thing works out, right? But I think we'll see more aggressive strategies as well, for sure. I mean, similar to Tesla. I mean, as long as you have the appropriate compute platform and sensor stack on all the cars, I mean, there's nothing stopping you from going all in on a high volume, not necessarily high end. I mean, it's one of those things where it certainly depends on the target audience, how they're thinking about it. I mean, a lot of people who buy Tesla, I don't know, and a lot of them get the FSD package, right, or ADAS package, and for them that is an important variable in buying that car, and they might be willing to pay that higher price. So it's a function as well of the target audience, I think, target consumer rather. But yeah, no, I definitely think we'll see more situations where you can immediately go for a higher volume, not necessarily on high-end cars.
Do we get to a point where an OEM ships the sensors on the vehicle, and then if the owner or lessee wants to unlock it, it becomes a software subscription? So the hardware's out there in the market, then they can just turn it on via software subscription?
Well, yeah, I mean, it seems to already be the case for Tesla, right? At least that's an option. So yeah, I mean, I think that it's just a question of like how aggressive does the automaker want to be with that kind of play. I mean, obviously the hardware costs something, but I mean, it's like even if you're not turning on the feature, you're still collecting the data, presumably, right, from that vehicle. So it still becomes a data collection platform. And then, you can think about it in terms of, okay, well, the software is at a certain level now. Once it becomes a certain amount better, it'll be even more attractive to that consumer. So they're going to be more and more likely to purchase. And you can play around with the pricing of it as well, right? So as we're seeing in the market.
And then I think at some point, subscription fatigue is going to set in with the consumers. I mean, we have the classic of pay a monthly fee to turn on your heat seater. We saw where that went. You have silly ones, and then you have practical ones. If consumer, I could see a consumer paying for automated driving features. I can't see a consumer paying to roll their windows up or down or heat their seat.
Well, I mean, yeah, you can't frame it as taking something away, right? Like, I mean, it has to be like a new feature that you're adding value, right? You can't take something away and say, pay me for it.
Yeah, the consumer will rebel. We saw that quickly get overturned. I have a vehicle, and the manufacturer will remain anonymous. It's not a very good vehicle, but it's electric. And they said, oh, for X thousands of dollars, you can upgrade your performance. It's silly. It truly is silly, some of these business decisions that are being made, but you're making a very wise business decision in licensing. As we go to higher levels of autonomy, there's a common denominator. AI is going to play a major role in developing higher levels of autonomy. What impact, in your opinion, will AI have on the future of mobility?
Oh yeah, I mean, pretty huge, pretty huge impact, right? So, I mean, AI is gonna be the key driver for, a large part of the software differentiation we're gonna see for, future car sales as a function of, starting with high-end assisted driving, going all the way through L4. And, I think that as we're discussing this distinction between also L3 and L2 and L4, I think what we're going to see, right, is there's going to be this intermediate regime where it starts as an L2 system, but then it can become actually L4 capable, even as an L2 system, without necessarily being rebranded as an L4 product. And so that intermediate regime is interesting because that means that, statistically speaking, you getting into the car and turning on that assisted driving feature is actually going to be safer than you personally driving potentially, right? It could be even much safer. But because it's not an L4 system, it can't go sleep in the back, right? That's not how the product's supposed to be used. But it can still offer quite a lot of safety benefit and a lot of convenience, right, to the driver, provided that it's responsibly used, right? So, yeah, so I do think that intermediate regime is quite interesting and I think will be possible potentially sooner than people think as a function of the innovations happening in AI. I think that, beyond even automotive, right, there's going to be a lot of innovation in robotics with similar technologies, right? So the unified approach that we take, right, to developing AI for self-driving cars can actually also be leveraged for, say, like autonomous mining or humanoid robotics. So I guess like in terms of the future of automation of robotics at large, I think AI is going to play quite a major role.
What are your thoughts on the humanoids? They're starting to scale up in China. I can't vouch for the accuracy of the reports or the videos, but from what I've seen coming out of China, it's pretty impressive. And I've spoken to some very large warehouse operators here in America, and they're betting heavily on them for a variety of reasons. What are your thoughts on humanoids, and how do you see them scaling?
Yeah, no, I think it's a huge opportunity, and it has kind of interesting properties compared to, it's not the same thing as the automotive market, right? And actually one really important distinction is that I think there's potentially even more capability to deploy very large AI models in humanoid robotics in terms of the actual online inference, right? So with self-driving cars, I mean, you're talking about a very safety critical application where, you have to make decisions, 200 milliseconds that could be, have very serious outcomes, right? And so that means that you have to do pretty much all your key processing on the car, right? It's going to be difficult for you to meet latency requirements where if you wanted to communicate with some offline server, I mean, it is possible to do that technically, but it becomes a very hard problem, and it's going to be difficult for that to be at least the primary way to do things. Whereas with humanoid robotics, you could have application domains that are don't have the same kind of latency requirements, right? If you have a humanoid robot that's performing tasks around the house or something like that, like you could even be, away at the office. It doesn't really matter. Like they can, pause and think for a bit. So you could technically have a humanoid robots being controlled by some offline server somewhere, and you could run much larger models in order to make that happen. So it's I think there's a potentially faster path to market for like an L4 equivalent for a humanoid robot or something like that, just as a function of the compute and the way that interacts with latency requirements.
Humanoid robots, I agree, they're going to scale. I think you're going to see them in commercial applications, especially in warehouses. And I was reading one of the largest labor shortages was in slaughterhouses, surprisingly. That was really interesting. So I could see them in those use cases where you have a labor shortage in automation. I can also see them doing certain tasks on farms. But there's a clear theme here. Automation and the humanoid robots are going to interact at some point, and they're going to have a dramatic impact on the global economy. I can't wait to see where Helm's going. It's going to be fun. You made the right decision on day one of going with licensing. I love your deep teaching approach to it, and the fact that you knew Jim Simmons was absolutely awesome and was the highlight of this episode for me. Vlad, for today, as we look to wrap up this insightful conversation, what would you like our listeners to take away with them today?
Yeah, I mean, I think if you think about the self-driving space, right, over the last several years, there's been, quite a lot of discussion about where it's going, about timelines. There's been these like huge investments that didn't pan out. And it's kind of like, self-driving is dead, long live self-driving, right? And I do think that, what's going to be potentially surprising to people is that the pace of AI is clearly accelerating. And I think that's, super evident when it comes to the large language models and things like that, like ChatGPT, et cetera. And that's kind of a very accessible thing for people, right? They can just communicate with this thing and determine how much better it's getting. And, oh, wow, it got a lot better year over year. It's with self-driving, it's definitely a bit more opaque, I think, for most people to assess. But I think the key takeaway from my perspective is that there's going to be, I think people will be surprised how quickly self-driving will evolve, given just the pace of innovation in AI, in the coming years. So again, I think that sort of, ChatGPT moment for self-driving cars is definitely coming.
The ChatGPT moment for self-driving cars is a lot closer than you might think. Today is tomorrow. Tomorrow's today. The future is Helm AI. Vlad, thank you so much for coming on SAE Tomorrow Today.
Thanks a lot for having me.
Thank you for listening to SAE Tomorrow Today. If you've enjoyed this episode and would like to hear more, please kindly rate, review, and let us know what topics you'd like for us to explore next. Be sure to join us next week as we take a deep dive into the search for Amelia Earhart's lost aircraft with underwater exploration company Deep Sea Vision.
SAE International makes no representations as to the accuracy of the information presented in this podcast. The information and opinions are for general information only. SAE International does not endorse, approve, recommend, or certify any information, product, process, service, or organization presented or mentioned in this podcast.